Alright guys, so today's question is going to be Jason is collecting quarters. He goes to the store with $4. If he asks the cashier for change in quarters, how many quarters will he receive for his $4? So let's go ahead and, as a first step when dealing with a word problem, let's go ahead and identify what we know. So we do know that he has $4. And because we want to know how many quarters he'll receive for his $4, this hints to the fact that $4 is actually going to be our whole here in this problem. So $4 is our whole. And because we want to know how many quarters are in $4, we know already off the bat that in $1 there exists 4 quarters, or in other words, $1 is equivalent to 4 quarters. So what that means is quarters have equal value. So if we divide $1 into 4 equal sized parts, let's go ahead and write that down here, $1 into 4 equal sized parts, that means that we're going to get the fraction 1/4. Because looking at a fraction, we remember that the denominator represents how many equal sized parts our whole is being divided into, which in this case, our whole being $1. So 1/4 could, in other words, represent 1/4. So there, we've gone ahead and identified our variables. So looking at this from an arithmetic standpoint, go ahead and use a different marker. We can rewrite this problem. Essentially what we're looking for is how many quarters will fit into $4, which is how many he'll receive from the cashier. So this can be rewritten as 4 divided by 1/4, because that represents 1/4 here. So it can be a little confusing sometimes seeing a fraction being having essentially a fraction in the denominator. So we're going to actually approach this using a set model. So we have some cash here. We're going to go ahead and represent our whole here, which is $4. There you have it. That's our whole. And because we know that 1 plus 1 plus 1 plus 1 is equal to 4, we can actually do some fraction decomposition here and kind of split up this fraction so it's a little easier to look at. So let's go ahead and do that. Let's go ahead and rewrite our whole, and we're just going to write it as 1 plus 1 plus 1 plus 1. So again, nothing's changed here. We've simply just split up our whole. So what that's going to look like from a numbers standpoint is 1, because we're looking at $1 here, divided by 1/4. How many quarters go into that dollar? And we notice that we split it up and we have $4, so that's going to be written 4 times. So now we have some quarters here, so let's go ahead and make that substitution here. We know that there are 4 quarters in a dollar by our unit fraction 1/4, being 1/4 plus 1/4 plus 1/4 plus 1/4 equals $1. So we're going to go ahead and do that for our remaining dollars here. 1, 2, 3, 4. We have 1, 2, 3, 4. Last one here. 1, 2, 3, 4. We'll go ahead and circle these just so it's a little easier to look at. Move these up some here. There you have it. All we've simply done is substituted our quarters for our dollars, and there you have it. Now we just got to add these up. Here we have 4 plus 4 is 8, plus 4 is 12, plus 4 is 16. So there you have it. 4 divided by 1/4, I'm sorry, is equal to 16. In other words, Jason will receive 16 quarters if he hands the cashier $4. Alright guys, so we're going to look at the same problem here, except this time around we're going to solve it using an area model. So here we have Jason is collecting quarters. He goes to the store with $4. If he asks the cashier for change in quarters, how many quarters will he receive for his $4? So we're going to identify a few things using some area models here. So we're going to actually represent our dollar with a circle. Next, we're going to want to go ahead and identify our quarters using an area model. So we do know, based off of prior knowledge, that there are 4 quarters in $1. So what that means is 4 quarters, 4 equal sized parts, comprises $1. So we can represent that by dividing our dollar here, our whole, into 4 equal sized parts. So again, nothing's changed, it's still $1, we've just divided it into 4 equal sized parts. And 1/4 is going to be simply just one of those parts. So that is equivalent to 1/4, otherwise known as 1 part of these 4 sections can be rewritten as 1/4 of $1. Now that we've gone ahead and identified what our area models represent, we can go ahead and solve this problem now. So we know that we have $4. Jason has $4. So that's 4 circles. And the question is asking for how many quarters he'll receive for his $4 from the cashier when he asks for change. So because we're looking for the number of quarters, not the number of dollars, we're going to actually go ahead and divide each of our dollars into 4 equal sized parts. So let's go ahead and do just that. Now we have them in 4 equal sized parts, each dollar. So now, based on our knowledge here, we know that one of those 4 equal sized parts represents 1/4. So all we have to do now is count. Go ahead and just write this down for reference here. That equals $4. All we have to do, like I was saying, is count how many quarters are in these $4. How many quarters is equivalent to $4? So let's go ahead and count those. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we know that there are 16 quarters in $4. So because he's asking for change, we do know that Jason will receive 16 quarters for his $4.